Okay, good morning, good afternoon, good evening in some places. Welcome, everyone. Hello, world. Welcome to Uptime 2026. Yokoso, Huangming, Selamat datang, Swagatam, Bienvenue, Willkommen. Welcome, everybody. This is a special edition of Uptime. It's 5 years since we very first started this program in January 2021, when we decided to get together as a community just after COVID. It was also the first year, as many of you remember, just after spectrum had been pretty much liberalized for private spectrum across the world. CBRS had been running for some time, but it was only in December 2019 that it was actually made generally acceptable for everybody. So that was a great time. We also had spectrum made available in the UK. France was earlier that year, Japan, Germany, all around the same time. So 2019, December, January 2020 really was when spectrum became available. So with all of that expectation, of course, we went into COVID, Mobile World Congress got cancelled. And in 2021, when there were big questions about whether Mobile World Congress would be resuscitated, that's when we decided to start Uptime so that the private 5G industry, which had been really led by lots of smaller players, such as Druid, Athernet, S-Band, Cable Free, many other players, who had been in it, we decided that we needed to have a little community conference, and that's how Uptime started. Really glad now that 5 years on, that we've grown to such a community, and I'm going to go through some of the lists that we have. And it's quite an amazing number of people who've joined this Follow the Sun event, beginning in Tokyo. I can see our first guests already logged in from Sumitomo. And we're going to finish off in the West Coast of California. So I think it's the world's only Follow the Sun tech conference. And we're going to follow the sun across the world and finish off with a beach party, perhaps, in San Diego or San Francisco. And I've got Dean Bubbly here, who's just walked in his beach clothes as well.
So cool outside.
Yeah. So what are we going to do today? So what we thought was, it's 5 years, as we said, since the spectrum was released. So we'll take a look back on what's happened in private 5G over the last 5 years. We will also be looking at, I've just looked at some of the numbers from analysts out there, and between 2000 and 2025, as we exited 2025, it looks like there have been about 5,000 private networks deployed across the world, private 5G network. We'll look at why it's taken 5 years to get to 5,000. So we'll go through some of those reasons, spectrum availability of radios, devices, etc., maturity of the ecosystem. And one of the questions that I'm going to ask all of the panelists and speakers today is, over the next 10 years, over the next decade, what will it take us to go from 5,000 networks to 500,000 networks? So that's a 100-fold increase, right? So that's one of the things that we're going to look for. The other theme that we have today is networks for the singularity generation. So what is the singularity generation? So the idea of the technological singularity has been around for some time. It's the idea that AI is going to keep advancing at a very rapid pace until it reaches a pace where the rate of advance of AI is so great that it almost becomes an an infinite leap. And many observers have been predicting this is going to happen around sort of, 2040, somewhere between 2040 and 2050. So in December 2019, just as we were going into 2020, the generation that was being born then is the generation that would come of age, reach 20 years old or 21 years old in 2040. So that generation born from 1st of January 2020 is effectively the Singularity generation. They're now about 5 years old. They're going to experience AI, technology, robotics, haptics, advances in science that are just going to blow everything that we've seen before. So what are the networks that are going to determine the lives of that Singularity generation? That's one of the themes that we're going to explore today as well. So these are the two key themes. Can we get to 500,000 private networks by the end of the decade? And how are these networks going to serve this new Singularity generation that is coming of age in these 2 decades? So that will be the main theme. In terms of the agenda today, it really is quite a spectacular list. But before I do that, I actually just want to propose a vote of thanks and just acknowledge Stephen Patrick, who's here. I'll just switch the camera around and get Stephen into focus. Let me get rid of the background, and there you go, Stephen.
Thanks, Nanda. Thank you.
Yeah. So Stephen and Cable Free, very grateful to you for hosting us in this wonderful boardroom, which is filling up with Dean Bubley, Alex from Antivia Networks. We're having a little watch and talk here as well in real time. So that will be happening in the background. So thanks again to Stephen. So on the agenda, what do we have today? We're going to kick off this morning in the usual fashion, beginning with Asia Pacific. So we're going to have presentation from Sumitomo Electric and Microamp, company from Poland, who are partnered together. And they will be looking at millimeter wave. This is something that's gone silent for some time. You may recall that when we first started in 5G, there was a lot of the early 5G, especially Verizon, etc., was with millimeter wave, but that was an NSA. But millimeter wave has grown up since then, and there's now an SA product, and we're going to look at that, and we're going to talk about what use cases millimeter wave is serving. So we're going to begin with that, beginning with Japan. We're going to have Hari Kumar, who's the CTO of XL Smart, talk to us about Indonesia, which is one of the most attractive countries in Southeast Asia for private 5G, and he's going to be talking to us about what they've done in terms of deployments in the mining industry and ports, in manufacturing, in oil and gas. Staying on the APAC theme, and have a panel that's being hosted by my old colleague Kunal Patel from Athernet and HPE. With Hari will be on that as well as with colleagues from VI in India. Then Pegatron, the largest private 5G smart factory in the world they're using. We're going to hear from Jayan Moge, who's going to be telling us about what they're doing and the use cases that they're having there. So a lot of these are now real private 5G deployments. And this is the big difference, I think, between 2021, when we first started. It was all about the technology, one or two really pilot demo projects and test beds that we were doing. Whereas in 2026, 5 years on, we're going to be looking at real production deployments. I'm really excited to be able to share some of these. That's going to be on about 8:45 a.m. UK time. We're then going to hear from Nitin Tavatia at L&T. L&T is one of the largest infrastructure players out of India. They are also a system integrator, deploying private 5G into places like airports, ports, etc. But they also have their own production facilities where they do fabrication, they make lifts, and pretty much all of the infrastructure in India, if I recall, is built by L&T. So it's really going to be interesting to hear some of their user case studies. That's going to be around 9:15. We're going to then at 9:30 another panel on Asia Pacific. I mean, Asia Pacific is really kicking off in terms of private 5G, even though it's one of the few markets ex-Japan where there isn't private spectrum available. The pent-up demand for private 5G type of use cases is so huge. And we're going to hear from Fadil Asari, who's the CTO of PT Corbec. Nitin's going to be there again. Mansoor Hanif, who many of you will know as head of RAN at EE, and then ex-CTO of Ofcom, and one of our inaugural speakers in the first uptime that we had in 2021 when he was director of technology at NEOM, is also going to be speaking. He's most recently been a strategic advisor to SMART in the Philippines, so he's going to be telling us about what's been happening as well. And we're going to have Louis Tan from ASCII, well-known manufacturer of radios, devices, etc., as well. So he's going to be giving us a feel from someone who's also got not just the infrastructure, but also devices. So looking forward to having Louis as well. 10 a.m., that's a couple of hours from now, is when we kick off the European session. We'll have Massimiliano Mezzinasco, who's head of private 5G, an old friend, who's going to be telling us about what MNOs have been doing with private 5G. So that's at 10 a.m. GMT. We'll follow that with a presentation from Cable Free, and Stephen will be giving us his own take in terms of how this market has matured. And Stephen's been telling me how this is the year that private 5G is really seeing big momentum. So that's going to be really exciting. We then have a European panel where Aline from Apirun and a former colleague of mine, also from HP and Athernet, will be doing a European market review. We'll have Justin Eichenlaub from the German market for M3 Connect. Mikko Uusitalo, many of you will know as one of the pioneers of private 5G deployments in Europe with Edgecom, where they began in LTE doing ports in Finland, and then got acquired by Bolden. I think there are about 130 networks deployed, so he's going to be on there as well. And we'll hear more from Sandrine Legrand from Microamp on 5GSA using millimeter wave. We'll then hear from Andrew Conway on Bolden Networks, 130 networks deployed across Europe, probably one of the largest operators both in Europe and the US, because they have networks in the US as well. So a really major player in private networks across the world. Dean Bubley will then chair a panel from this very room where we're going to be looking at deployments in the UK with Alex Smith, who's sitting here next to me, from Antivia Networks, Matt Stagg from Neutral Wireless, who did one of the first private 5G broadcasts with the BBC. We're now going to move and kickstart the first session. So that gives you a flavor for the first half of the day. Second half of the day, beginning from 1 p.m., will really be focused on the US market, and I will update you on what we have in store. Last, before we bring on Sumitomo and Microamp, I just want to tell you that one of the big questions we've had in this industry since November, when Nokia talked about how they may actually pull back from private 5G, is what will Ericsson do? And I'm glad to say I'm really honored to have Ericsson here for the first time on Uptime. And so they will be here in the late afternoon, and in fact they will be beginning with the panel on robotics that we have at 5 p.m. GMT, and then closing off with a dedicated section on Ericsson. So I know it's a long day, but please bear with me because we've got Ericsson right at the very end, and they will be really answering some of the most often asked questions in the private 5G industry. What's Ericsson going to be doing in private 5G? So that's a quick run-up, I think, of what we're going to be running through today. So with that, I'd like to invite my first presenters onto the digital virtual stage. Sandrine Legrand, Hiroshima Miyata-san, could you please switch on your cameras? I can see you logged in, but I think you just need to.
Yes. Can you hear us as well?
Bonjour, Sandrine.
Bonjour.
And Hiroshi-san, konnichiwa.
Very good. So I'll be sharing the content. Hello, Hiroshi. Thank you.
Okay, so I will hand over to you both.
Sure. Oops. Try to go full screen. Oops.
And you're live.
Thank you, Nanda. Thank you for inviting us and for hosting us with UPTIME. My name is Sandrine Legrand from Microamp, and I'll be presenting today with Hiroshima Miyata from Sumitomo Electric. We are very honored to be kicking off the UPTIME webinar and to be the first presenters here. We'll be introducing a new aspect of private 5G, which is how the use of 5G millimeter wave opens up a whole era for private 5G. And to start with, I will be introducing our companies. So Microamp, which is the global leader in 5G millimeter wave. We manufacture our own 5G millimeter wave radios. We provide as well the end-to-end GNODBs in millimeter wave, our own GNODBs. And we are a European company based in Poland. I'm not sure Sumitomo Electric really needs an introduction. They're the global leader of optical fiber cables, and they offer broadband network systems. And we are presenting today because Sumitomo Electric has developed a DAS technology based on our 5G millimeter wave technology that enables to expand very efficiently the 5G millimeter wave signals into indoor deployment. And we will have three parts today to our presentation. The first one is for those that maybe are not that familiar with 5G millimeter wave, explaining what it brings to private 5G, and also deconstructing a few myths about 5G millimeter wave. Then I will be sharing an outdoor use case that Microamp has in the port of Dublin. And I will hand over to Hiroshima Miyata, and he will be presenting the DAS technology that they have developed and how it really enables to distribute the millimeter wave signal in indoor use cases in a very cost-effective way. So to get started, really, let me share a few things about 5G millimeter wave, what it brings, and deconstruct a few myths related to 5G millimeter wave. So what first is 5G millimeter wave? It's using 5G in higher bands, in high frequency bands that are typically 24 to 25 gigahertz bands that are now widely available across the globe. And what this enables is, because we have a large amount of spectrum available in these bands, it enables us to deliver a multi-gigabit capacity in downlink and in uplink. And here we are speaking 4 gigabit per second per radio overall, and up to 1.4 gigabit per second right now with our technology in uplink. With very low transmission delays. So very important, we are below 5 milliseconds round trip time in terms of latency, so a very low latency with a very low jitter. So it really enables to have real-time decision-making application running over 5G millimeter wave and around across private 5G. As I mentioned, we focus a lot on uplink traffic. What is important is to deconstruct something that we very often hear about 5G millimeter wave, which is that 5G millimeter wave does not propagate well and that therefore the links are very short. In fact, as we will be sharing in the use case in the port of Dublin, we can see that now with very efficient 5G millimeter wave technology, we can extend the coverage over sometimes a few kilometers very efficiently with a very high throughput. So it's really an coverage that is now available and that is made available by 5G millimeter wave. And same as in lower bands, in sub-6 bands, of course, we bring the same capability, which is that we provide a reliable connectivity because the spectrum that we use is separated from public cellular and Wi-Fi networks. So that's really the different elements of 5G millimeter wave that make us say that we bring to the market a fiber-like wireless. Now, in terms of the technology that Microamp has in its portfolio, we have some radios that are indoor radios, others that are outdoor radios. We really cover both type of use cases. We are coming up next quarter with an all-in-one radio, so really the CU, the DU, and the RU together in the same equipment, which is pretty important for some of the private 5G deployment. It really makes it much, much easier. And this is available in all bands that are available in Europe, in Asia, in the US, so 24 to 29 gigahertz. We exploit 800 megahertz of the spectrum. This is what enables us to deliver the 4 gigabit per second that I was speaking about a bit earlier. And just to really emphasize a bit more, what we're doing is that we're bringing to the market the first dedicated millimeter wave layer 1 implementation. So that's really the first one that meets the impact and the promises of 5G millimeter wave that were made 5 years ago. And we provide a technology that delivers in terms of coverage, performance, and cost what was really expected but was not available 5 years ago. And this is what we showcase with this first use case, which is an outdoor deployment in the port of Dublin. Here, what we do is that we are connecting a number of high-definition CCTV cameras over links that are 1 kilometer or over in Dublin, which is not the place where the weather is the best. So really showing that it can operate reliably even under adverse weather conditions, so including rain. And we run over these CCTV connections, some real-time video analytics applications. So really demonstrate the high uplink, low latency, and low jitter that the technology enables. And that as this is working very efficiently, our customer is now adding new applications and services over the network that is there. And typically, we're now adding backhauling of 4G and 5G BTS to this system. And now that we have proven with typically this sort of use cases that millimeter wave outdoor works very efficiently, I'm going to hand over to Hiroshi that will show how millimeter wave indoor can all be very efficient and can be very efficiently distributed in different rooms potentially using the DAS that they have developed based on our radios and GNOBs. So Hiroshi, I am handing over to you.
Thank you. This is Hiroshi from Sumitomo. Firstly, I'd like to express my deep appreciation to the Uptime for this great opportunity. Also, I'd like to express the deep appreciation to Microamp, since this solution was made possible by strong support of Microamp. Well, let me start. I will introduce our millimeter wave ready distributed antenna system. We call semi-DAS. The semi-DAS is designed for indoor use. So as you know, DAS is a system with multiple antennas, spatially separated antennas, and those are connected to a single source. So that distributes the cellular signals and to improve the coverage and signal quality. The typical special feature of the semi-DAS is millimeter availability, as I've already mentioned. You cannot find this kind of solution in the market, I believe. And in addition to that, the remote node of semi-DAS is quite small. It's a 10 centimeter by 10 centimeter by 6 centimeters. You can see this? Can see this? This is a remote node. It's a palm size, very small. This small body allows the integrator to install DAS very flexible. That is a big advantage. Then next. So when we talk about semi-DAS, the audience always asks 3 questions: the impact of fading and interference, and propagation range, and also the impact of body blockage. Today, I'll address all of them. Next, please. So as for fading and interference, we have measured the signals in our conference room. It is a carpet floor and drywall. The conditions are depicted in the left-hand side. We prepared 2 antennas, RNs, and we measure the 2 cases with 1 RN and with 2 RNs. The result is in the right-hand side. The upper row shows the calculated result. It is based on the free space propagation model. And the lower row shows the actual result of the measured result.
2 minutes to go, Hiroshi-san.
Yep. So the result is very close. So it means that the fading impact is very small. We can say that. We don't need to care about fading so much. Next slide, please. With regarding to propagation range, I will show you the video. So in the middle, so the CP is moving from the just below the antenna to the counter corner of the basketball court. It is 32 meters, and in the middle, it still keeps the 900 megabps, and at the end, it keeps the 500 megabps for downlink. If you accept the 500 megabps, it is you can make, it means you can make more than 3,000 square meters of area. It is quite huge area for the indoor use. Next, please. So this slide shows the body blockage impact. So several people are walking around the UE, and they try to disturb the radio signals, but the impact is not so big. Then the 2 guys want to completely block the signals. but it still have the more than 600 megabps. We can say that it is impossible to terminate the signals with when we use two RNs. It's very stable to use indoor use cases. Next, please. Next. So here is a possible indoor use cases. Typical one is arena or concert hall, which is offering the multi-view broadcasting. And the second one is smart warehouse factory or smart factory. So there are many AMRs and humanoid and drones are working together without any collisions. Next, please.
Okay.
So here we will have a live demo on the MWC. Please visit our stand and see you then. Thank you very much.
Thank you very much, Hiroshi-san and Sandrine. Thank you very much. We have a packed session this morning, so I know there may be questions on this. And what I'd suggest is we've got a European panel later on where Sandrine is on, and maybe we can address some questions there later. One of the questions that comes to mind for me is, it's very impressive what you're able to do with the semi-DAS and the throughput that you're getting. Would like to know a little bit more about devices and the ecosystem, and maybe that's something we can discuss later on the European panel. But thank you very much, everyone. It's the first time that we're seeing it here. DAS on millimeter wave. You saw it for the first time at Uptime and Mobile World Congress. You can find out much more about it. Thank you very much. So with that, if I may ask Hari from the next presentation to switch on your video.
Hi, Nanda. Good day.
Hi, Hari.
Yeah.
So,
how are you folks doing in Oxford today?
no, we're doing good. There's a nice group of us here. It's rainy and wet, so I think we all wish we were in Indonesia with you today for the weather at least.
Okay.
So we've got a packed schedule. So I'm going to hand over to you, Hari, CTO for Enterprise at XL Smart, one of the major players in the Indonesian market. So Hari, over to you.
Thanks, Nanda, and thanks to the Uptime folks today for this opportunity. Let me share my screen. Okay, Nanda, you need to cue me if you can see that presentation on.
Yes, we can.
Yeah, okay.
Perfect. You're good to go.
All right. Let me also see if I can connect to the audio so that when the video plays.
Gopal, could you mute your video, please? Yeah.
Okay, I can select share sound. I will just start first, yeah, Nanda. All right, good day, everyone. Thanks for the time today. We'll have a look at the Indonesia digital transformation. So I've been asked to talk about 5G network deployments or private network deployments and the challenges we have in Indonesia. So yeah, my time starts now. Just a quick introduction. My name is Hari, and I'm the Chief Technology for Enterprise Business here in XL Smart for Business. So I have over 20 years of experience in doing telco solutions, IoT, data centers, and the likes. A quick overview on XL Smart for Business before we move on. So XL Smart is part of Axiata Group and also a part of Sedamas Group, the largest conglomeration in Indonesia. So if you look at the screen here, let me see if I can do a pointer. Yeah. So Axiata operates in different countries. We have 5 opcos in Cambodia, in Bangladesh, Sri Lanka, Malaysia, as well as Indonesia. Where else? Our second shareholder is actually Sinamas Group, largest conglomeration in Indonesia. We have industries in pulp and paper, agribusiness, land property development, bank and financial services, health services, and the likes. So it puts us in a good, unique situation where we can leverage the best of the telco and also into industry applications with our sister companies and parent company. As for XL Smart itself, we actually have we have few brands in the retail market for B2C, and then for the business, we have XL Smart for business doing the B2B. We have over 80 million subscribers nationwide, and there are about 9,000 corporate clients, ranging mostly on connectivity business, and we provide SD-WAN, cybersecurity, and now moving into industry solutions. Our coverage nationally, we have about 168,000 fiber pops, so we are present nationwide. That enables our reach of connectivity, whether it's for HDC or putting a private network right at the edge or right on customer premise and connect to the nearest fiber BOP. As far as BTS are concerned, we have about 200K or more than 200K BTS across the country. So this is the overview on XL Smart. I'll give you a quick overview on what we are focusing on the B2B solutions. So there are 6 product pillars that we are focusing on. And this is definitely, we started with the voice messaging and big data, and the mobile fixed connectivity as our second pillar. The third one, we are focusing on cloud and security, which is also picking up. We see good traction over the years. Fourth one on ICT products and services. This can be on-prem DCs. It can be on software stack that they run on, and so on. Now, our fifth pillar is something of interest today. So we have a product pillar just focusing on private network and IoT. And this, although it takes a longer sales cycle, a bit more customized product to sell, but we have a team to actually look into this. And the last pillar is on AI and other emerging new technologies that are coming. Now, within these 6 product pillars, we actually try to focus into 5 vertical industries. So natural resources are one, so that's into mining, plantation, and others. Manufacturing is the second one, and this is where we see a lot of traction happening in terms of industry deployment. Healthcare public sector is the third industry. FSI and retail, so a lot of connectivity on ATMs, branches, and moving on to SD-WAN, how we optimize the traffic, and then going to security, how we actually help them at edge using SOC for cybersecurity, as well as within employees or contractors connecting into the system. We look at EDR or XDR solutions. And finally, technology and service provider companies. These are the 5 verticals that we focus on. Moving on, just a glimpse for everyone today, because I understand from Nanda and the organizers that you are coming from different countries. So Indonesia is actually we see Indonesia to have a good growth potential in terms of digitalization. So market intelligence from Modor and also other reports shows that from 2026 this year, total digitalization market size is about 29 billion, out of which almost half is actually on IoT market size. And this growth is continuing to be double digit for the next 5 years to 2031, where IoT market size is forecasted to be still quite solid at 42% of the total digital transformation market. And out of this, 5G private networks are estimated to be slightly over $2 billion. So in summary, in short, what we look at is we're seeing the market traction to be quite big. The growth potential is big in Indonesia, where it's a vast country, many islands, a lot of rural population, and industries in rural areas. Now, if you look at what are the key drivers that are going to support the growth, either on the IoT side or the connectivity and the digital transformation side. The first one is definitely a telco-driven 5G as well as low-power WAN network. So not everything that needs or not everything runs on 5G, but certain applications, especially on low data rate telemetry runs on low power WAN network. So this is one big thing that will power for the next few years, because Indonesia has yet to auction certain bands for our 5G network to commence or to scale up. Second, there's a big push under the government for making Indonesia 4.0 manufacturing. The adaptation of digitalization and automation is still low. Certain sub-industries like automation or automotive industry is quite mature, but others such as edible oil or even oil and gas, and looking at other sectors on textile, pulp and paper, they are still low on the maturity on digital transformation. Third one, we see a big driver in terms of smart cities that are being rolled out and backed by government. Smart city adoption is happening in the private sector, but on the public sector, on the government-based or government local council, as well as township areas controlled by government, the adoption is still low, and there's still much room for growth for whether it's flood monitoring, traffic, security, and so on. And the rest are AI based CCTVs, and there's satellite connectivities, as well as ESG. So these are the key drivers we see in Indonesia. The first 3 years, the one that I elaborated on. Now moving on, what is our experience? So I think this comes to the crux of the matter. So what have we done? We have deployed and we see good traction in mining. So I'll be talking about 2 use cases doing in Kalimantan Island. And next, smart port. So that's another one that's picking up because of the volume that's involved and also the massive devices and sensors that are needed. And thirdly, on smart factory. So we have deployed certain solutions in smart factory. However, these are using a hybrid network. So it's a public-private network together. So using network slice. Now I'll go on to the smart mining case. So this is a remote bulldozer setup that has been done in South Kalimantan. So now I'll probably play the video and see if you can. Nanda, can you?
Sorry, Hari?
Yeah, I'm going to play the video.
Yeah.
See the way you guys are hearing the sound.
Okay. No, I'm not picking up an audio.
You're not picking up the audio, yeah?
Yeah, no.
So I'm going to stop here and see if I can reconnect.
Yeah, you might have to just enable share computer sound, I think is the magic.
The option is not turned on.
It's not?
I can turn on the share sound.
You're right, it doesn't seem to.
Okay, I'll just continue for now.
But I did a test yesterday with someone else and it was working.
Okay. So basically what we have done here is, this is on the trailing pond, right? Where the leftover or the waste material from the pit processing or after the conveyor processing is actually dumped back into the earth to fill it up. So the working condition is really bad. So there's high risk and safety issues for the operators. Let me put my pointer now. Now, because the ironstone, the height of it is higher than the bulldozer itself, there's always a risk of landslide and other high risk working condition. Plus, these areas are very hot, very dusty, and these are actually poor work environment for humans. So by doing a remote dozer, a container was placed several kilometers away, closer to the workers' mess, and it's running on aircon. So an operator can actually sit in a comfortable environment and do remote control of the bulldozer on site. So this has actually been deployed successfully, and the customer is happy that it's going to be expanded into different vehicles there. So that's one. Second one, we did a similar project in another site of another customer or another location. So on East Kalimantan. So this bulldozer is even better. There's CP on board, and there's CP is actually integrated to the CAN bus, and there's a CCTV and a two-way voice system on the dozer. This connected to a few sites around, and that sites are using mobile tower and CCTV there as well. And all this is brought back into a local IT office with local servers and using private network. Now, the good thing about doing this is it reduces the downtime because there are shift breaks that you have to send the operator all the way to the bulldozer location, but here you don't. And more importantly, it reduces the human fatigue rate and the related errors. Because imagine working in a dusty, hot environment, the attention span actually goes down very fast. Whereas sitting in a cabin in a control room with a good environment that actually avoids the fatigue rate. And finally, of course, the accident reduction in the high-risk zones. So we see many of these cases happening in mines. And beyond bulldozers, we see slope stability sensors being connected, and also the visual AI visual analytics along the hauling road. So those are the things that's happening now. Moving to the next project or next deployment experience, I'm going to talk about a smart port. So this is something that we did in Jakarta Port together with some of Nanda's colleagues. So if you see, where do private network come in? Private network comes in when customers start experiencing a challenge or the performance limit of Wi-Fi access points. Because traditionally everybody wants to do Wi-Fi because it's something they're comfortable with, the IT teams are familiar with. So in this port, this is a specific terminal within the bigger port area. So they were using about 370 watts Wi-Fi access points, and they had problem on interference, they had problem on maintenance because not like all access points are working, and then they had problem with the maintenance and the repairs, and they also had problem with the handover because whenever they switch the access point, there's always break first before it makes. So we came in and we did a trial with 9 G-Node Bs on 7 poles, and this is how the coverage simulation looked like. So the idea was to connect CP on cranes as well as tablets that are used for their automated operations. They already had a digital system, they had a software. The connectivity was the problem. So we actually tried to use the connectivity to do the CP and tablet connection on real time to the command center. Now, one of the issues we challenged or we faced was actually the containers being stacked. It can be up to 3, 4, 5 containers. So that created a valley or a canyon effect where no coverage was bad between. So we had to design RF such a way. And secondly, there was also uplink density was high compared to the downlink. But after deployment, what they can see is the throughput and productivity increased close to, it was between 10 to 40% depending on the shift. And the turnaround time and logistics velocity improved a lot because of the reliability and the near real-time connectivity that we can provide, as well as it being can handle massive amount of uploads at a given time. This video, again, I'm not sure if you see the audio, but I'll just play this video. This is the video that we compiled after running or deploying this location. Let me see.
Connectivity issues at seaports cause delays in data transmission.
Okay, Nanda, I still cannot do the voice share sound.
and disrupt cargo management, impacting overall operational efficiency. Smartphone for Business offers stable connectivity and low latency. A robust network supports seaport operations, enabling real-time monitoring and efficient management of cargo, personnel, and equipment.
Hi, Hari. We're not seeing a video. If you're sharing the video, I think you're not sharing your screen. You're probably sharing a presentation. You may need to share your whole screen, but we could hear the audio, but we couldn't see the video.
Cause delay.
Can you see the video now?
Connectivity issues at seaports cause delays in data transmission and disrupt cargo management, impacting overall operation.
No, not yet.
No.
But maybe we can stop there, because I think we're now going on to the next session, which is the panel, where you'll be there as well. So maybe we can take some questions and talk a little bit more about that over there. So with that, I'd like to invite Kunal. Can you switch on your camera? You're going to be sharing this discussion session.
Hi, everyone. Good morning, good afternoon, and good evening.